Good morning. Good morning. Namaskar. This is Yasura Singh speaking from Bharat, India. On this day, June 15, 2021, Tuesday, and team talk about quality. Major point is quality and relation to civil field engineering, engineer's role in COVID-19 regarding quality, designs, construction, method, contracts, organizations, communications, coordination, quality, structure, and why should we be behind quality. All these issues can be covered in this brief talk. I am saying brief means it's not very long talk. It can be conducted for many hours. But sorry, we are limited to certain hours. Person like me and person like those who are having certifications, competency certification like chartered engineer, like professional engineer. These certificates indicate competency in their profession. If those having these certificates, statutory certificates like membership, fellow member or associate, or corporate membership, that's called all three, AMI, MI and FI, or corporate membership, which endow on everyone the responsibility of what you are, how you do, how you perform, how you conduct. Everything is specified of conduct. And if these professionals, if these professionals also act like ordinary professionals, like ordinary citizens, and they don't bother about quality aspect, though majority of them bother, but botherance and converting requirement to reality are two different points. Either you believe in quality, you convert that quality into reality, or you do not, you believe in that but you are not having enough strength for conversion of quality into physical world. Some people believe quality but they are not too strong in doing that, while others neither believe nor do that. Both of these classes I cannot call professionals because they are paraprofessionals. Means if somebody does it, they accept, or it's I have done it. If somebody does not accept that, they ignore that. This point is not for criticism. This point is for world and particular in our country, India, Bharat. And I'm interested in writing COVID-19 relation to quality, relation to role of engineers, because role of engineer applies everywhere in life. My purpose of this certificate was to show to you that just do not believe in certificates alone, because certificates tell something but people do not do that. That point we must understand. It's not for everybody, but for general it is, that people should believe in quality, not only believe it but work on it. My experience, whatever small it is, insignificant it may be, but it's a reality of world. If you work at many locations in world, many thousands of you have worked at many locations in civil engineering, construction engineering around world, in Middle East, in Gulf countries, in West maybe, or countries like Iraq, Iran, Libya. Those who have worked in many countries, there will be many people like me. Just for your information, I have worked in Iraq, Libya, Qatar, Abu Dhabi or UAE, Saudi. Means certain countries I worked in. What does it indicate? It indicates that you should have different experience, varying experience. I have been opportune to work with more than 50 nationalities of all ranks, all designations. This means one who is exposed to many nationalities, one is bound to have certain exposure to new type of work culture, new type of you can say people's nature. Everybody does a worker coming from Far East or working come from West or working come from Middle East or working from Africa. Everybody works, but efficiency, quality, status, and conduct all vary. In our country, India, Bharat, you will find different states. Culture is not very much, varying. Mindset is same in our country. But when I worked here for so many years, what I noted, and when I met outside with people and worked with them, I of course found little difference. In 1980s, you can say quality here was also different. People were little serious in those days. When I'm talking, I started my career in, say, junior career in 1975 and full-fledged career in 1981, because in 1974-5 I was appointed on basis of my 3-year civil engineering diploma, and I qualified my remaining sandwich education from Institution of Engineers India, and that was called Section A and Section B of IEI, which was equivalent to, and which is also equivalent to, degree in engineering. So I completed my engineering degree in 1980, and or you can say got certification in 1981. I had no plan to stay in India that time because I was not happy here, keeping in view negligence, ignorance, carelessness, corruption by various people, various engineers. I was employed in government sector, state body, statutory body, where I worked for 6 years, and whatever I experienced was too bad. So I was there only to fulfill my education requirement. I had decided not to leave this country without doing full degree. And once I got that degree, I tried for overseas appointments, and by chance I got to work opportunity. I got work opportunity in Iraq. My first entry was in Iraq. I was of course in different world now because I never saw any foreign country by that time. So I landed in Iraq in 1981, and what I observed there was quite different. Quality could be understood there, means such high level of quality I had never seen in our great beautiful country. Quality millimeter by millimeter, you can say step by step. Every work was checked like it was gold. It was very important for project. Females engineers were seen, young engineers were seen. Everybody looked to be very, very serious. People used to fear those engineers that time in Iraq, government engineers, you may say resident engineers, who were in charge of supervision of job. I met many resident engineers, many you can say middle engineers, and also consultants. Role they played with work was really, maybe I had not that much experience by that time, but what I could understand, they were very serious professionals. I met their Jordan engineers, Egypt engineers, or many other country engineers, British engineers, you may say our engineers. And what I found that they were serious in job, and we had to learn from them. way with which work was done, and procedures under which, within which works were examined or inspected. In those days, there was no quality system like ISO 9001 and also others. So, quality was defined differently, specifications were given, drawings were clear, very complicated but hard work drawings, and I used to enjoy reading those drawings, studying those drawings throughout night, many hours at night, because in daytime remained too busy on sites, and at night maybe up to 12 o'clock, 1 o'clock, 2 o'clock after taking food, tried to stand on board, keep hard copies of drawing, prints of drawings, and study hundreds of drawings of buildings, over there. I worked there in 3 companies in Iraq, and I still remember two engineers who were from you can say Iraq, and also one engineer lady in Iraq. I worked in, you may say, I worked in Saad al-Thri in Baghdad, Sharkat in Mosul, near Mosul, and of course Mahmudia. 3 places I worked, and I met very, very great senior resident engineers who used to be very strict in quality controls, quality in the examination. They were engineers, were serious, and I was happy to see at least those people who checked millimeter by millimeter. They have their assistant resident engineers, both from foreign countries like Bangladesh or Pakistan or their own or Egypt, like that. And they were taught only one thing: you do not leave anything undone, unchecked. I never heard that kind of talk, that kind of discussion in our Bharat. I never even could imagine that people could go to that extent, because in our country 1 millimeter, 1 centimeter, 1 inch, oh no problem, it is only 1 inch, why do you worry about that? But no, there was even 1 millimeter a problem. If you do not do job rightly, because you were I was contracting company, I was a contractor, that job would not be approved. And it's all concrete, it's all concrete. At that time concrete was very much important, very much controlled. And I still remember in those days I saw all those machines which 20 years later or 25 years later entered our country. Concrete pumps, which they claim now this is reciprocal. People don't even know what sort of pump is that here. But there I used those pumps in 1981, 82. I used, reciprocating pumps, mobile pumps, excavators, shovels, and like that, many, many more such machines, which I could not that time even see. In catalogs you could see, and of course there was no internet, no computer. So somebody told me it's opportunity to learn, and that person was right who advised me that you could not learn you could not even see these machines in our country, these earth moving machines, high heavy equipments. You can see here, they won't see anything. At that time it's right, means now everything is there. I'm talking of 1981, 82, 83. So I tried to learn, means I was surprised to see that hundreds of cubic meter excavations could be done in hours by using excavator, or if it's mass excavation, by using shovel. Shovel, now they call JCB or something, but actually shovel is a different machine. It's very heavy, about 175 HP, and excavator is also same, about 160 or 70 HP, which will be, this HP means brake horsepower of machines, very heavy. So I was that time very much surprised to see that so fast excavation could move on, and concreting could be done so fast, which in our country was at that time remote or distant dream. Well, I was lucky. So you see, one, if you're lucky, if you go to such sites, maybe I was interested in designs that time. So I must be a designer, very good designer. I had an ambition of that. Designer means, and particular RCC designer. I was not interested in structural steel, but RCC design was my hobby, my baby, my ambition. Of course, I did that, but it broke later on because sight collapsed into my mind, sight occupied my mind, and sight, you can say, encroached on me. I had no time, believe me, to even open books sometimes, so busy on projects. Round clock, you can say, concrete goes on, say it used to go on for 24 hours, 48 hours, 72 hours, depending on quantity. And you have to stay there. If you now they don't allow, they stop concrete, and means this could not even be possible. I still remember first slab that we poured in in one tower in Iraq. How, to what level difficulty I faced, because I did not know work culture. I did not know how to arrange, how to organize materials, how to organize batching plant. That was that time batching plant. How to deal with approvals, how to deal with materials, how to arrange for all this so that everything goes in time. And one time I did not even calculate quantity of concrete, and we started concrete. There was shortage of sand, there was shortage of something else. So at random, at random hours, we arranged for everything. But because I was from subcontracting company, it was exclusively not my responsibility. It was the responsibility of main contractor at that time too. Well, we did that, and of course, some difficulties arises in life. I still remember a time when I was in, there in one project in army in, I forgot name actually. That was Saad something Saad in Baghdad, where I was in charge. I was doing all duties of manholes. You take care of these manholes, external sewerage line of that area, very good circular manholes, and every manhole was to be inspected at every level, excavation level, blinding level. I don't understand that time, but you have to get approvals from them. Excavation, blinding, then preparation of reinforcement, its levels, everything for manholes. You see, it was not building column; it's manholes. And every time you call them, these female engineers from Iraq, you call them and request them, and they would reject many times. I was surprised. She rejected something. Why rejected? Because it's 2 millimeter different. It's not right. Do it again. Oh, I see. And our project manager or director used to say, "Oh, it's only manhole. Go and excavate. Do it. It's nothing. It's not project. It's not building. It's only manhole. You do not make a concrete 50 manholes per day, 20 manholes per day, like that." Used to say as everything was so easy. Means those also had to think that work is too easy. They did not keep in mind quality system, because our that project manager was from Bharat, India, of course, South, and also same person, another person from Bharat, India on another project. And I was in Sharkat Grain Silos project, whose ancillary buildings I was taking care of. That buildings. I still remember one time, there was one, I still remember one name of that resident engineer was Kifa. My colleague who has left now is gone, Mr. Chauhan. He was taking care of road project there, RCC, paving. Told me, so this Kifa is very, very dangerous. Everybody fears him. Though it was EPI company, which was main contractor, and nobody could face that resident engineer. And don't argue with him, because he's very, very strict. I said, what strict? Let me see. Means, I still remember 2 or 3 instances. He talked to me due to some activity I was doing on site. And first I submitted my design of one slab, That design means there was a slab left on one building, it's a workshop building, I still remember. Design of, you can say, roof, one slab was left, it was not done by PI to some reason. I did myself, and we did it, though it was very small. Still design is designed for me that time, manual design, everything, drawing, and we gave approval. Now one time I was standing, to fix cat ladders on one building, because I had to, building structures are over actually. I had to take care of finishing items, and finishing I never worked on, but I said no problem. So plastering has to be done somewhere, flooring has to be done, sorry, and then roofing had to be done, like that, various types of, I planned for that. Some pergolas, gargoyle we used to call them, gargoyle we used to cast on roof. Gargoyle means water outlet, in water outlet from roof, and just let water go down directly from that RC precast unit, no downtake pipe. Like that we did all, and that resident engineer all supervised everything. At one instant I see, step, this cat ladder, which is I think not more than 9 inches maximum projection, or 6 to 9 inches, or you can say 15 to 152, you may say 235 or something, that much He tell me if person stands, it may come down. Well, I got it. So they said if some person stands on that, this may break. He was asking me a question actually. He says this is not strong enough. It shall come down or it shall bend. Well, I was surprised with this question, and I said, okay, do you know, Mr. Kifa, what is bending moment here? How you calculate bending moment? It's very easy. Means, let me consider maximum weight 70 kilogram, 80 kilogram, 100 kilogram. You don't think more than this somebody will go up? Only somebody will go up because this is not accessible roof. It's inaccessible. That's the reason we have put in our scat ladders, so that everybody cannot move up. And if you see weight of maximum 70-80 kilograms, you have the maintenance person, or let us say 100 kilogram. This is just 15 centimeter or 6 inches. You can say 15 centimeter, and this is like cantilever, and we are putting a steel step in. This means, what is bending moment here? It's only 100 kilogram into 0.15 meter, because 15 centimeters, 0.15 meter. So you can say 1500 kilogram and 2 decimals gone. So this is 15. This is 15 kilogram, 100 kilogram into 0.15. This means 15 kilogram meter, right? 100 into 0.15, 1500, 2 decimals gone. So 15 kilogram meter. What is that? You think it's very heavy? And if you see resistance of this bar, it is 2.3, let us consider mild steel, 2.3 tons per millimeter square, per centimeter square. It is 16 mm, or I think it's 20 exactly, I don't remember, let us say 20. Where do you stand, Mr. Kate? You think it will come down? He was smiling. No, you're right. He was testing me. So I told my friend, see, he talked like this and explained to him like this. Oh, you talked to him, you responded to him, you argue, you should have said, no, Mr. Kefa, you're right. Oh, no, I can't say like this. It is engineering, means we argue as engineers. Why should I say, okay, fine, he is in charge of this project, but he is in charge of engineering, he is not in charge of hello or how do you do. He is not, a diplomatic in charge, he is a technical in charge, and maybe he likes to see everybody fit for this job. And he is educated one, that's why he raises questions. That must be agreed. So, not one instance, many instances he used to talk about this whenever he met me. So, he actually looked to find people who are good in technical. Because I was from designs at that time, I knew very simple questions these were. And I still remember these, these people from EPI, Government of India body, they used to remain in panic because, oh, Kafa would say this and Kafa would say that. Do it fast, do it correct. You see, who would say what? My question is that. He may be from government or he may be from non-government. It doesn't make a difference. The difference is how do you respond. Response is more important, and if you, because on sites, engineering, construction, it's very important. You have to be good in designs, you have to be good in construction, you have to be good in resource handling, like workers handling, machines handling. At that time, all advanced machines were available there. I means I was at that time, and all I could see in that age when I was just maybe 24 years, 25 years. In that age, I had to see those machines. Of course, I moved on, but I still remember those days. I still call those days quality days, particularly Iraq. I don't know, I thought all over the world same level of quality existed. My first entry was in Iraq, and it was fortunate that I worked with such quality oriented people, engineers. I met with them and they taught me, actually, to be very frank. It may be engineers or other juniors. Some, what happens in those days, what happens is, I say, those who are experienced technicians or experienced artisans like carpenters, like masons, they were employed as supervisors because they were to supervise, not to do job. They were they were deployed as a go and check shutters, alignment, go and check reinforcement, or go and check levels of shutters. Like these duties were given to those very senior, experienced persons. I still remember a person, many times I told you before also, in that project of Darul Thawra Press Complex building in Baghdad, 1982, and I was there. He used to, when we used to call, I want to get this columns checked. This person, he did not look in, he was very old, and of course he used to come and see, I want this, and he said, what do you want? He did not explain, but explain in a way that you try this examination method I am giving you, only then I would come and check. So he said, use thread lines, this and that, and he explained this. You do like this, then I will check. And actually, he taught me what is building axis. I mean, professionally went to examine building orientation, columns orientation, or you can say grids location. You use building axis and use grids first, examine them, and then you go to see something else. I still remember first time we prepared 4 column shutters. 4 columns, big columns, not small column shutters. I thought that he will come and inspect it and say, okay, pour it. I was so sure. But when this person came, he was not an engineer, of course, but he knew more than engineers know. Somebody told me later that this person he worked as carpenter in his life, former carpenter. I said, I thought a carpenter, what shall he check? When he started checking, well, I got crazy, you can say. Whole day wasted. He did not approve these 4 columns. Whatever he wanted to explain, we did it then, means I want 1 meter line from here. You have to take first check grid line of this columns both ways, not one way, and you establish that with reference to access line, I mean to say control line of buildings both ways, in this direction and in that direction, or you can say x axis or y axis. Then both ways you fix the strings, and we have to make sure that position or orientation of column is okay first, and that too at top and at bottom is 4 meter height column, or in between 3.5 to 4 meter. You have to establish first bottom is okay, and then you have to establish that top is okay. After that I will check your plumb, and plumb must be at 2 places on one side, 2 places on other, orthogonally. And believe me, it took us long time to arrange establishment of grid lines from access lines in both ways. Then put the strings. For establishment purpose I had theodolite. We used to do that. Theodolite, we call it theodolite at that time. I had also labels, dumpy label. Label was not a big problem for me because I should do directly, somebody was not available, but theodolite, it took some time to set it. Then grid lines were established, taken from down. We were on, you can say, 6th story I think at that time, 6th or 7th story, and this was taken from down, or surveyor reflected it, puts it on that floor, and grids were sent around. So access was established in both directions and grids were established, and from those grids, you see, from this axis of column you take it 1 meter outside this way and that way, fixed thread at bottom, then fixed thread at top from there itself. Bottom was fixed. What did he say? He calculated in his own Arabic language. This is 1000, this is 100, this is 18 mm ply, 100 he capped, and this is 18 mm ply, this is 75 mm or inches, in inches, this is your batten. Sum of this is this one, and I deduct from 100. I should get this much measurement from my thread. Okay, you show me this measurement here at 2 points to make sure that bottom orientation is right. 1 millimeter, no problem, but if it's through 3-4 millimeter, you have to correct it. Same thing, you take it to top and establish positions first. When you have bottom fixed means reliably fixed, and you have to make sure if plumb is okay in both directions, measurements of sides are okay, down, at bottom and at top, and you can establish top position is okay from grid itself, because we had grids of columns we established in both ways. From those grids, dimensions were measured. Grids is there, dimension can be measured, means from this grid so many centimeter this is and so many centimeters that. So if grid control applies there, your top position is also okay. So bottom is okay, top is okay. What is left? There may be vertical error in height, which plumb shall do. Plumb in both directions, plumb not at one point, plumb at 2 points in one side. And those were very sizable columns, 80 centimeter by 40 centimeter, in some cases 50 centimeter by 1 meter, in some cases T-shaped columns, in some cases L-shaped columns, in some cases cross star column, like that. So sizes were, you can say, reliable, good, and I am sure at that time we were using working stress method for this multi-story tower, high-rise tower. It was high-rise, 20 story, more than 20 stories. I think the tower on which I was working was about 14 or 15 stories, and there are 6th or 7th floor, lower tower and the upper tower. This tower was very high, so they were very serious too because it was going to be fair face concrete. Okay, fair face concrete. So this is my first experience in structural engineering execution. So we followed what he said. He checked each and every orientation of column in both directions. He went up and checked dimensions from grid itself, and then he checked plumbs at two locations on each side. Then he said, okay. One by one he did. He smiled, and I mean he could not express in his own language, but his language was that, okay, you are doing now something. So I was relieved when he said, okay, concrete it. It's okay. Okay, we concreted it because he was not responsible for concrete, for steel. There were some other engineers for pouring and for steel check, reinforcement check. But when we did it successfully, he came after shuttering was removed, after 48 hours. He said, okay, yeah, the curing was ongoing, that's not a problem at that time. Hose pipe was available and we used to cure by water method. We are working on some other forms. He suddenly came and did not tell us, and he started checking post concrete activity. See, we never knew that time that there was post concrete investigation or post concrete inspection. He tried without telling anybody, came and said, I was surprised the guy is doing. We met him. No, I am just checking whether casting was right or just some error. Okay, I was sure what can be there. Well, there was some in first time, second time, nothing happened. But one time he detected an error of 40 mm in location of column. Oh, he detected that. None of us could detect. And of course it was somebody's fault, a surveying error, which could not be avoided because of negligence. Of course I said it's my responsibility, I am not surveyor. I did not do that, but because I am project in charge here for this tower, it's my responsibility. Well, I'm not going to depth of that. What I'm saying is, such people were devoted, they were dedicated to quality requirements. For them, everything was quality. It was measurement, it was dimensions, whether it was a plumb or orientation of column, or you can say other people, for them quality. How did they pour? What happened? It was not a systemized one, but it was applicable. That's the point we have to be serious about. Application. What I'm preferring is that such people were available in those days. I'm talking about 1982, 81, you may say 40 years back. 40 years back, I'm talking of what was engineering construction world. That was what. It was not one experience, there were many experiences, but I still remember that time when we had to dismantle our one column and one thin wall of 150 mm thickness. Due to column was taken out due to wrong survey, and it was out of line by 40 mm. You can say orientation was wrong, and we had to remove that column. And of course there was bulging in RCC wall, which was fair face, big wall. There was bulging, or you can say opening from sides in the elevation, and nobody accepted that. One time even resident engineer told someone, you are not experienced, you are not enough experienced, show me your certificate from where you qualified. Are you qualified or you're not qualified. Such level of argument goes on. And I didn't know all this could happen, that such errors could lead to investigation of my certificate. My experience was discounted. My efforts were discounted. Well, that time has gone. I proved later. Give me one time. One time they said, no, you are not experienced. They told my employer, get somebody else, and this person is not experienced. But later I changed myself. I changed my working style, and I had to take responsibilities directly on my, for example, survey responsibility, and all other responsibilities I had to take on me, because I did not trust surveyor because of mislocation of 4 centimeter column, 4 centimeter mislocation of column case. Who will accept such surveyor? Maybe he played with me. I don't know. Whatever he did, that is his blessings. But it was lost to company. His reputation lost our company, that main contractor as well, because main contractor is also disreputed. In this case, your column is broken on site, and also there were many other. Means I was on down path at that time. But when I retied my belts, you can say, I rejuvenated myself. No, I have to take care of myself. It is question of my reputation. Then I changed everything. I involved in every activity. And of course, when you are beaten somewhere, you change yourself, that is true. Experience, or you can say mistakes, errors, all these become your teachers one time. Experience teaches you, errors teaches you, all errors teach you. My error was that I trusted people, and I said, no, you trust people, but not unlimitedly. You trust them, but keep an eye on them. And everybody was then, of course, that surveyor had gone, then it was out. Then you can say virtually I was surveyor too, in addition to being in control of concrete, all concrete, and other works. I involve myself everywhere because of that setback which I got. So only I am saying that quality required everywhere, and in every activity in life, and in engineering it is a must. Is it yes or no? You have to tell us. No way out without quality. Quality has to be complied with. Defined requirement. No future if no quality persists. Engineers must realize quality effects. And in particular, civil engineers have to change quality aspect of society, or else quality cannot exist. Systems quality to be devised. When I say devised, means designed and achieved. Broken system means broken life linked to system. Broken system means broken life that is linked to system. Professionals individual quality to be amended, and one must be forced to amend its quality for reliability by additional teaching and by additional knowledge dissemination. Relevant element or product defined quality to be achieved. Individuals required attitude quality to be streamlined. Individuals' dedication to be applied on actions, work commitment to be made and fulfilled for delivery. All other parameters to deal with pre-requirements and requirements, designs of structures and others must be decisive, qualitative and reliable for prosecution. All stages, designs being significant, but merely design does not suffice if construction and development are not affected to specified marks. Quality be allowed to be ignored. Quality to be allowed to be ignored Design drawings must have quality input. Design drawings must have quality input and duly coordinated to produce working details, keeping abreast site working conditions. For site cannot be relied upon automatically, but give clear notes, specify properly and explicitly. Construction based on reasonable, coordinated, constructible, quality designs. It's a very important point. Construction based on reasonable, coordinated, constructible, quality designs. All activities must be taken care of, but it doesn't happen. Reasons being lethargy in attitude and undue strains in minds. Why should site work suffer? Why? Because of deficiencies in designs. Design accountability must be fixed. If accountability or constructed product or element is required. Design accountability must be fixed, it says, if accountability on constructed product or element is required. Design and construction qualities are complementary to each other, and without integrated coordination, activities worked upon shall result in quality less results. These are just few statements that I make in interest of quality, and also construction method statement, a must for implementation. Must for implementation, and that is because I put my leg little up, because expression of specific details in convenient format. Convenient format means usable format, readable format, not very complicated format, for work performance, and define elaborate performance, or else no work can be carried out in sequence and output suffers. Expression of specific details in convenient format for work performance and define elaborate performance, of course, or else no work can be carried out in sequence whereby output suffers, resulting in bad standards of working. Method statements must be made necessary for activities implementation, or else diverse ways can be used by site teams. Diverse ways, not one way. And diverse ways means a problem. Diverse ways can be used by site teams without achieving any level of uniformity and consistency. You may say work harmony may not be found, work scaling cannot be found. One team does one way, other team does other way, so uniformity cannot be found. Time is irrevocable, for never it comes back if lost without controls. Unchangeable within controls, and then we can say cost invariable escalation. Risks must be foreseen, for resolutions, for damages are not tenable. Risks must be foreseen by an professional, by an intelligent person. Its foreseen must be for resolution, not for enjoying. If you can foresee risks, it means you are an experienced person, You are a person who keeps thinking in various aspects. Risks must be foreseen for resolutions, for damages are not tenable. Damages we cannot absorb every time. And these must be controlled. What? Risks. In advance, inexperienced engineers may prove inefficient in viewing such risks based emergencies, and therefore thorough deliberation of brainstorming must be conducted based on available data input. Risks must be clearly defined to reach its resolution and to convert to work convenience, or else risk can be very expensive in terms of lives and cost. Reliability must be accessibility defined and achieved. Reliability is equal to safety from all involved factors plus serviceability of intended purpose plus durability of its working life plus all other involved applicable knowledge, areas, factors, resources must be understood and achieved in all procedures, or else one should learn before taking responsibility, and all foregoing issues must be considered along with all possible risks. Analysis, or professionally a master tool for work contemplation. It is a very important point to say professionally a master tool for work contemplation is an exclusive engineering basis and intellect tool that can penetrate into all problems. An exclusively engineering basis and intellect tool that can penetrate into all problems and thereby unearth required solutions. And there exists no way from where or through which analysis approaches could be avoided. A must all problems to be understood by this approach. This is, very much, you can say, concept of quality which we have to take care of. We cannot take quality for granted. Quality approach is various, is variously immense, it's varied. Quality at different levels is defined depending on funding and depending on goal in life. When you pay for something, what do you think? You should get that or no? You should get that. That's what everybody thinks. When I pay for this, I must get that. That is simplest form to understand quality. You pay me back what I pay for. If you don't pay me back what I pay to you, then this is an incomplete transaction. You charge me, but you are not giving the service. Well, I think that's right point. That's right point. Same thing applies here. Same thing applies here in service. If I am employed engineer somewhere, engineer in contracting or engineer in consultancy or wherever, third party, I am paid. I am paid my service charges, my salary, let me say. I am paid that salary for what? My employer expects that. I am paying you that. And because I am paying you that, you have to pay me back. Pay me back product for which you are responsible. That's the right point. That I have to pay back. So pay back what? You have to pay back quantity of production. You have to pay back quality of production. You have to pay back time of construction. All these points you are required to pay back to me because I paid to you. And you have to do work according to contract requirement. That's also your job. It may be design contract or it may be work contract, construction contract. You are paid for both. Construction contract payment goes to contractor who is responsible for construction and quality, quantity, and other payment goes to others. This question is not because in one hand you are paying and other you are taking back. You have to fulfill your job description. You have to fulfill what work was given to you. That's the main point. If I cannot fulfill that, means I am wrong somewhere. I am not faithful. I am not loyal to my job. Loyal to job is important. Being loyal to job. If I am not important, my face is not important, my job is important. What quantity I am giving, what quality I am producing, giving, to what extent this project moves on safely in terms of economy, in terms of cost, in terms of quality controls. All those factors are kept in my mind. If some point strikes in my mind, no, Suraj, no, this is not right, you are wrong, it may strike me in my mind, which reference I have to think of. I have to take care of that, what comes to me. I must accept that or reject that, either of two. I have no interest in someone else. I am only interested in profession and in my job and that project I am dealing with. So in that case, I have to be very clear. See, non-compliance is not compliance. Non-compliance is non-compliance. You can't change it. You have to amend it. No other way out. If you can amend it, you'll be happy. And if you don't amend it, keep it in secrecy, and by chance that paper, somebody of you reads and you know more, what shall they say? In that case, we have to be very careful. That's my point here. Now, because this is quality, I'm out of all time. Synthesis is an analytical based engineering result. To apply an analytical based performance, analytical based engineering result, that's called synthesis. To apply and to apply an analytical based performance provides a chain of solutions that can be named synthesis. After all, solutions are integrated for quality, requirement of suitability. We have to understand these basic points before jumping on to what we say. If we can handle this, well, I think it will be better. We can handle, we can understand. If we can, it shall be much better than something else. So that's what I say is important. And now Here's a list of titles of quality requirement that we are going through so far. These titles are very important for day-to-day engineering of everyone. If you deal with, if you supervise or you construct, it doesn't make a difference for both. These are important. If responsibility of contractors to supply something for quality requirement, there is a responsibility for contracting people for whom construction goes on. They are supposed to. So we have to be very careful in this approach. We cannot take it for granted. Quality is very important matter. Quality loss means product loss. Quality loss means reputation loss. Quality loss means future loss. Now you have to read this list. It's an important list. You can realize what statements I have taken and how many I am going to take now. Very, very important statements shall come in your way, which are based on my experience alone, no book support, just experience by site work or office work, building work. All those are in, and you may, we may all you know experience that. Meanwhile, I'll be back in a few minutes. Alright, gentlemen, sorry for little delay. I can't leave birds also. That's the important point. Now, this list I showed to you. I've gone through various points, various methods which you have. I was talking of concrete pours actually. Concrete pours of various items just talking about. And let's take that for granted now. No, we can't take for granted concrete pours. We also suspended slabs, then we talk of many pours. Yesterday I did not talk of this. Let's take this way. Let's take this way. Let's take this, lift valve. I repeat from here because this is very important item, lift valve. Lift valve, maybe some people not have clear idea about this. As I said, this is very important item. You have lift, it has a valve. You can see this now. I'll show you this sketch again because the sketch tells so much in that. I just try to remind what we discussed before. Which is maybe you have heard it before, you have seen it before, but it doesn't matter. It doesn't matter that you can't take it again. And that is, lift. And this is my management documents here, and you can say I go to method statement sketches, that may be traffic. Form, wall lift form here. Now this is just a formwork diagram of lift. Diagram you cannot say is detail actually. This lift, what I to say that this is, you can know this is shutter and internal external both shutters of lift. I talked about this in explanatory notes, explanatory discussion on how this formwork is erected or installed temporarily as preparatory work to receive concrete pour. I'm not going to explain again what is this, but I'm just trying to explain something in this, that you have to make sure before pouring all these details are done. It's not one day job. Depending on area available, you can see just 4 meters by something, 3 meters approximately. So you cannot keep undue resources on this to finish this job in one day or half a day or 4 hours. No, that's not possible. It takes time. You may not keep more than 2 or 4 carpenters inside and 2 or 4 carpenters outside. It's not going to work. You have to see, you cannot engage 20 carpenters on this and work. No, that's not. If it's a big area, it's okay. It's not big area. Or it may be a lift bank, which I have not discussed yet. Lift bank means, for example, is a lift orientation like this. There's another lift here, same. Then there's another lift here, you can say 2, 3, 4, whatever number of lifts there, you can call them lift bank. With similar details, only difference is that If I say keep this one lift here, it becomes a bank, of course, with two lifts, but then this wall becomes common to both. And same way, if I say I keep one here, one down, so these two walls of this lift become common to other two lifts. So you will say scenario changes. We'll discuss later on that one. This drawing is not ready. I can, if I find this drawing, I can change that. That's not a big deal. But here now, what I'm saying, how to pour it, that's point. This is ready as it is. This is platform inside in lift well area where lift bit is shown, and this platform is here. This platform is for workers to stand on this, keep vibrator on this, and have access to this portion from whatever best possible way depending on site location. You have to come in, work from inside, as well as you have to be outside somewhere and work from outside. Important in this case, inside is more controllable. Outside can also be controlled, but inside, if you control from inside, you can convenience yourself, you can access this wall, all these four walls with convenience. And if you stand outside and control from outside, this is not that much convenient, because here you need individual platforms. Of course, platforms otherwise you need also for walking, all that, but not like this so heavy platform here above lift pit and in lift well. So that's only difference. But how to pour it is point. First you make sure that everything is inspected, everything is checked, everything is reliable, and you have to make sure that your calculations were right. These won't fail calculations about forces coming on this. Forces from concrete, forces from resources of people, for workers, forces from somewhere else. Whatever is coming on this preparatory work should be digested, is registered. Registered by what? Registered by these bolts provided in, registered by the supporting system, all sides we have. This, this by these scantlings or timber battens and ply, all that. These three items can say systems of plyboard and your scantlings or timber pieces, wooden pieces. These supports inside as well as outside. These bolts. Per meter, you have to calculate that. You must have calculated before doing all this system, otherwise you would not have done it. Then you have to see that calculation was right. And in case if you, by chance you made an error, you can close these supports and add more supports to compensate for that ignorance. That can be done. And you have to make sure that whatever was done, because it's not one day job, it might have taken 1 week, it might have taken, so in 1 week there could be any imbalance. So we have to just make sure that whatever was done is still intact. So this is not slab that will come down, it's only valves, but quality of work must be important, because verticality is more important in this case. Shape of lift well in plan is more important. All these corners must be in design coordinates. You have to make sure before pouring. I will check again, double check, because during preparatory works, installation or erection, there could be some moment, there could be something which every day we noted. Otherwise, I don't want to see. You don't want to see twisted concrete. Nobody will like to see it. When you see from top into lift well, you'll say, oh, what a well it is. Same you see from bottom, see what a shaft it is. And that's mind everybody wants to use here. So we have to make sure that this works. And once you make sure, of course, you are going to place order for concrete. And point of order is very different. That its height is say 4 meters. Door height is say 2.2 meters. If it's 2.2 meters, means above portion where where door concrete starts again on top of that door opening, it is about 4 meters minus 2 meters, which you may say 1.8 meters concrete above door itself is there. I mean to say, this is door, concrete is going to come somewhere here. So in this portion, concrete will come as this shape, and you know, up to this height. This portion, there is no concrete because this is void form. This is no concrete form, but form is essential. This portion shall hold this jam, and this portion shall hold this jam. That's purpose here. So we can say that when it will not take much time to make sure that everything is intact, the support is intact. It can be seen by random check, or it can be seen by sending some carpenter, reliable carpenter, to make sure everything is fine, or some foreman to show. It's actually make check, don't leave it. It's okay, you don't assume anything. Because this question of bulging out of concrete, this question of, you can say, failure of platform, which can result in accident. Generally it doesn't happen, but sometimes bad time can bring everything. So your job is to check, don't feel bored in that. Examine, check, examine, investigate before danger comes, before risk comes. That's what is risk control, and this also a part of risk control. You can say we can control risk like that. If you can control risk like that, you are a good organizer, you are a good contractor. I can say you are a contractor because you are working for contractor. It doesn't mean that you should be contractor, but contractors, engineer means you are more responsible because you are doing work for that contractor. So you know all details of technical nature. Maybe you are not aware of commercial nature, but if you are manager, you organize, you are also knowledgeable about commerce. But here, okay, you are not concerned with commerce, you are concerned with technical. But technical is important, that's why you can say commercial important. If technical is not important, you can't say commercial is important. Technical work leads to commercial gains. That's the principle of construction. If you construct it technically okay, technically suitable, approvable, commercially automatically it becomes approvable. It depends on your way how to use your resources for best, or you can say optimum gains. And your resources like human resources, equipment, every minute, every hour counts, don't forget. So we have to be smart enough ourselves. Engineer has to be smart enough for purpose of doing job and getting job. So what I say now, this 4-meter height, how shall we cast? That's another point. That's the important point to discuss. I'm not going to touch this now, but how to do it, I'll explain that one. But important point here is in 2.2 meter height we have a restriction, and that obstruction is door. It's not free well. Means if I want to pour this portion up to 2.2 meters, I can't freely pour. Means I have two restrictions here. One jam on this side, this end, and another jam this end. These are two major obstructions up to a height of 2.2 meters, or you may say 5 or 6 layers, or 5.5 layers. These cannot allow me circulation to my will. So what should be done? And this is not such a place that 2 pumps can be installed in this location. Already it is 4 meters by something, 3 meters. So there is no question of 2 pumps installation. Only one pump can be useful, and if others are there, you can't take immediate action on them. So what I said, we have to pour these 2.2 meters or 5 or 6 layers concrete, 400 mm each, in little tricky style. Tricky because pressure is involved. Concrete horizontal pressure, concrete vertical pressure, or you can say concrete resultant pressure is involved. Concrete forces are involved, bending moment is involved, and because bending moment is involved, automatically ring. So what to do? Let's point here. Design technology or something that applies? I would say no. It's common sense that applies. When you pour sub slab, don't you feel annoyed if 10 pores, 10 what you call, 10 steel members? Now, we too see when we receive concrete after taking all tests etc. means let us say it has come to site of pour after clearing quality check, slump temperature, ambient temperature, and whatever was planned to be checked, cube shall be taken there only after it's approved. Means our slump is approved, or you can say there's nothing that cannot be controlled. So in this case, we have this area starting from here, you can say this air up to this cross, this cross, this indicates your dough, no concrete in this. We have one boom, remember, not two booms, and quantity per 400 mm, or you may say 500 mm maximum, approximately for calculation. You have to find square section area and multiply by that thickness of layer so that each layer's quantity is known. And if you take above 2.2 meter area, that is 5.5, that is 25 by 0.1. Now we have two jams here, door jams, which actually control start, which actually gives control start of pouring. We cannot start from either corner here or corner there. Sense says we start from here and move down. How many meters it is? Can say 4, 8 and 6, 14 meter approximately movement of this lift. Tight shear tape. Just that many meters. You got my point? 14 into now when we start from both ends, or we can start only at one end because other end is not, we don't have another pipe, another chute. And you see speed of how speed can be maintained. Let us say you got 8 cubic meter mix. 8 cubic meter. How much is there required? I can write in method statement. Let us say it is 4 for 8 and 6, 14. 14 minus 2, 12. 12 into 0.4. 12 into 0.4 into 4. 12 into 0.4, let us say 12 into 0.4 into 0.4, one layer I say. 12 meters into 0.4 thick width, 12 into 0.4 into 0.4, 0.16, 0.16 into 12, 0.16, 12, 0.16, So you got 14 into 0.4, that is 5.6. 5.6 into 0.4, 5.6, you may say 5.6 is 0.5, 0.4, that is, got it? 14 to 5.6, 5.6 into 0.4, 1/4 of 5.6, that is about 1.5. Let us say 1.5 cubic meter in one layer, and we have, you may say, how many? 8. So five layers you can pour with this resolution. So you have to see how many layers shall we. Again I calculate 8 into 0.4, 8 meters into 0.4, 8, not 8, 4 4 8 is 14, 15, let us say 15 into 0.46, 15 into 0.46, and 6 into 0.4. 15 into 0.4 is 6, and 6 into 0.4, 6 into 0.4 is 2.4. So about one truck shall deliver 3 to 4 layers. This means we can cast these 3 layers rapidly. We have to start from dot jam. You can say we have to see from top what level concrete has come. Generally people use torch for this. No problem, you can torch, but you have to move concrete fast. Means in a way, how much time it takes for pouring this, maybe 1 hour for this grass, or 2 hours. So we have to move from jam to other jam very fast. It's there. I apply for vibrator. This way we can say we have laid one layer. It may take half an hour possibly, or 15 minutes. Second layer, you start from that point you started. Don't start from end point. Where you started initially, you start second point from there. Before, let us say, gap of 5-10 minutes. A gap of 5 minutes. So when we first run and complete one layer, we come back to original point and apply vibrator simultaneously. You should have applied one after other, and because it's not going to take that much time. So this is step 1 we have taken for first layer. Vibrate and immediately lay second layer and third layer accordingly. So you have reached approximately 1 meter, and you can hold there for about 15-20 minutes, maximum half an hour. But after leveling third layer, that's very important part. Yeah, let me show that. So what says now? It says that three layers are over and vibrated before it converts to a front join. Let us understand what says. It's very simple. See, you have to pour whole wall. That's important here to consider in one go if we can. We should. It's not very difficult. After you clear, it's 2 meters means about seven layers you have to pour. About 7 layers, it will become maybe 2 hours by that time in layers, and evaluate that. Then you can say 1.8 meters. It is at top. Here you have to be very careful because 4 meter height means pressure is heavy, and we don't want to put pressure on form unnecessarily. Means we have to then above door whole circuit is to be concreted because this is a square area. Again I can say same quantity except door little 30 increase not considerable, it's very small. This is 2.2. This is you can say 2.2 height, and it is say 2 meters. 2 meters into 0.4, 0.8, 0.8 into 0.8 into so it is not very difficult to pour these layers. Now I can say if you read this statement, it will be very clear from that what it says. It says, just for your refreshing I'm reading, checklist for here it is 175. I put 175 and let's see. Checklist for RCC lift valve walls concrete pour, little complicated pour it is, and it is prior to doing something on concrete, pour activity, review calculations that were worked out to ensure that resisting forces provided by various components of supporting system of formworks are at least twice than imposed forces actions by concrete in full height pour, and also whatever force could be expected by working crew and vibrators etc. be containable. Make sure that wall preparatory works have been approved for pouring. Check all working platforms on both sides of lift well internally and externally are safe. I mean to say safety from every aspect, from forces aspect, from working forces aspect. All safety must be taken care of. Check all working platforms on both sides of lift valve internally and externally are safe, which may be installed from either side of walls. Make sure that access working platform is ready to safety engineer satisfaction, duly tagged at all risky drop-able height areas. Ensure that preparatory works have been approved and ITP signed off. Make sure watering into wall works as well as all supports being intact. Make sure attendance of steel fixers and carpenters for responding during emergency regarding reinforcing dislocation, bars, correction and controlling formwork sites opening or some other requirement urgently. Check the plumb wall lines remain in position. Plums and wall lines, I mean to say wall locations, remain in position to monitor accuracy on setting out alignment during ongoing concrete pouring activity. I just put that so that I won't lose this. Make sure attendance of steel fixer, ensure that preparatory works have been approved and ITP signed off. Make sure that watering into wall works as well as all supports being intact. Ensure that preparatory works have been approved. Make sure watering into wall works as well as all supports being intact. And make sure attendance of steel fixtures and carpenters is a very important point for responding during emergency. Regarding reinforcing dislocation bars, correction and controlling formwork sites, opening or some other requirements urgently. Check that plumb and wall line remain in position to monitor accuracy on setting out alignment during ongoing concrete pouring activity. Make sure that all supports remain in place, all clamps and bolts being intact. Make sure attendance of steel fixers and carpenters for responding during emergency of sides opening, steel reinforcing bars, dislocation, or to meet whatever other requirements. Make sure that competent pouring gang is deployed for required duration. Make sure that vibrators are available and are in working order. Make sure that standby vibrator 2 works in accordance to requirements. Make sure that all curing arrangements are intact for immediate post-pour application. Make sure the concrete pump and first in transit truck mixer arrives as advised to plant. Make sure the additional reducing size outlet of boom pipe is attached if so required, keeping in view consideration height of bore and size of column section. Arrange quality requirement control engineer for testing purpose. Concrete has to be cleared for delivery to concrete pump after initial site tests are completed satisfactorily. Ensure weather on concrete temperature. Ensure weather and concrete temperatures before allowing truck to deliver concrete to station pump. Make sure the vibrator reaches to lowest layer of concrete. Make sure that layers are not poured at one time more than 400 mm deep. Make sure that vibrator needle does not touch formwork. Make sure vibrator needle does not touch reinforcing bars. Make sure that everything is okay. Explain to concrete supervisor that pouring has to be started in such a way that corners are poured first to have concrete move in all directions uniformly to certain extent. Pour cannot be collected at any point within wall forms randomly, for it can cause pressure difference on form sides anywhere, leading to movement of form which state shall cause major problems. Lift well is a complicated pour which requires uniformity on concrete pour to maintain concrete fluid pressure at constant level all around pour periphery. Suggested that site engineer must take direct responsibility of such complicated pours, whether it is single lift well or lift banks wells. Make sure that concrete layers are formed around lift well forms and due care taken for door position formwork. Pump boom has to keep in moving around preparatory works to allow uniform layer thickness pour. All layers have to be vibrated thoroughly, gradually, and concrete has to be capped on pouring till 1 meter height depth is poured around. Make sure that at least half an hour a gap is allowed to pour so that poured concrete sets to certain extent but does not form cold joints. Pour other layers over previous until 2 meter height depth is raised and then allow say another half an hour for resting. Continue whole height pouring following specified sequences and start curing initially, as explained previously. Make sure that top of poured concrete wall is roughened for making construction joint. All walls outside forms have to be kept wet and top portion covered with polythene or wet soaked epoxy. Well soaked Hessian, Hessian. Check external forms as well as internal forms by strong hammer impact to find in case some voids to exist. During application of vibrator, make sure that repetition of forms would not be required soon, which means that there would be no earliest requirement to strike. Do not allow removal of forms. In case of such, make sure that repetition of forms would not be required soon, which means that there would be no earliest requirement to strike forms in specified duration. In case of such non-early requirement of striking, do not allow removal of forms after 48 hours, but keep curing intact from top as well as from outside. Allow removal of forms when it is to be repeated for higher level. During monitoring of forms, make sure that lines do not go out of tolerance limits, and if so happens, try to reinstate by tightening supports. After striking forms, make sure that defects are identified for raising non-compliance report and recommendations of remedial actions. Obtain and apply to close non-compliance report. In fact, this is very interesting pour in my life also, because I did myself standing on site. This was a project where I was involved. It's a high, this tower portion of Daral Tower. There's a bank of lift wells on core. One end was one was staircase going up to top, while on other end was core, which had 4 lifts. I think 4 or 3. I don't exactly. 3 lifts. One goods lift and 2 passengers lifts. And I had to do one in Doha. That was in 2004, I think 2003. There was one lift for record building. I had these 2 chances. There are more buildings as well, but it was not that type. So I can say I got good experience of these ports there. It's a good one at that time too. Then we can go to, I can close this file of lift. No problem, I can close this now. Checklist for RCC longitudinal staircase. For longitudinal stair I have shown many times. There's so many points in that, but let us see what is that. How many points are there? I can say there are so many points. 27 points. So let me finish that. I'll close this talk later on. Says check whether single flight or complete full flight have to be poured. That's the point here. But generally, practically, what happens? We pour only one flight. First flight we pour with bottom slab and top. Second flight we pour with top slab. This is usually done, but there is no hard and fast rule. Let us assume this way, and we can say that okay. Check whether single flight or complete full flights have to be poured. So check live list for RCC longitudinal stair concrete pour. Check whether single flight or complete full flight has to be poured. How to pour. Make sure that straight flight works. Have been approved for pouring. Single flight pour requires one portion along with landing to be poured. Make sure all supports are intact below forms. Make sure that all reinforcing bars are intact and steps, forms, risers are securely, correctly fixed and connected. Make sure that all cleaning has been effected. Make sure that inspection has been conducted and ITP signed off. Make sure that side edges, supports for waist and risers are well anchored. In case complete full stair flights have to be poured. Make sure all supports and steps forms are intact and well anchored. Make sure make sure that all reinforcement bars remain in correct positions while walking on steps. Risers forms which should not twist in either direction. Make sure that cleaning has been completed. Make sure that pumps or crane has been positioned at right location so as to cover stair reach. Quantity of concrete in stairs is not considerable, high in volume while it is slow in pouring as well. Generally, upper flight is planned to be poured with upper floor slab. Make sure that all concrete tools used in pouring are available in working order. Make sure that curing arrangements are available on location. Make sure that concrete is commenced with being poured from lowest step area and continue to ascend towards landing portion. Vibrator is required to be applied at all steps locations. Portion of waste slab and step sections have to be cast monolithic and accordingly vibrators applied. In case of single waste pour, a stop end has to be fixed at possible lower level of upper flight. Landing has to be poured as a small slab along with its downstand or upstand beam as case may demand. Finish on vibrated surface has to be applied in such a fashion that a rough surface is available to receive floor finishes. Immediately after pouring is over, curing has to commence with. For case of complete pouring with slab, work of pouring has to continue as explained. Stair forms shall remain in position until all forms of slabs are struck, with exception of vertical sides of waste slab, which can be removed post concrete 24 to 48 hours. Curing shall be considered an important activity as it is difficult to stagnate or pound water on steps, respecting which saturated Hessian shall be laid, covered over with polythene sheet. Continuous water curing shall be required even after spraying curing compound. This is very important pour of, you can say, very important pour, and we have to consider about this.